My guest again today is David Dilley. And David, what are we talking about here today?
Well, we're going to be talking about 5, 6 to 7 different subjects, tying it all together and showing what is going to be happening in climate change and what is false in climate change also. I'm going to show you proof of it. This is real science, and we shall go from there. We have a lot of data to show. Okay. I am, of course, here at Global Weather Oscillations, and specialize in ClimatePulse Technology. I'm a former meteorologist, NOAA, National Weather Service, and the United States Air Force. And right now I'm the senior researcher, meteorologist, climatologist, Global Weather Oscillations, 50 years experience. And we have 2 websites, www.globalweathercycles.com. That's the easiest to remember. And our principal site is globalweatheroscillations.com. I developed here at GWO ClimatePulse Technology. It's proven science. It's really the electromagnetic interactions between the Earth, Moon, Sun. And I use it for hurricane forecasting. I put out landfall predictions 6 months in advance before they occur with about an 87% accuracy. El Nino predictions going out 2 years, and of course, climate change, which we're talking about today. And I have about 4+ climate videos, podcast interviews on the 2 websites, which you can go on and view. And as we gather our thoughts today, and this is my little helper here over on the left side, and of course, they have instincts. And he says, my instinct says, use common sense. And that is what we're going to do, common sense. First of all, I want to ask about 7 questions. Is the rise in atmospheric CO2 since 1850 100% due to the burning of fossil fuels? True or false? Well, false, of course. Global warming did not exist prior to 1850. That's false. I'm going to show you quite a few global warming cycles. 2024, last year, global temperatures warmest on record due to the burning of fossil fuel. I'm going to show you that is false. Number 4, rapid decrease in the ice extent in the Arctic due to burning of fossil fuels. False. Are the melting ice caps caused by 5 natural cycles all occurring at the same time? We finally have a true. Was the 24 season last year, warm global temperatures due to 5 natural cycles all peaking at the same time? Definitely true. Are calculations of historical atmospheric carbon dioxide accurate? False. And I'm going to show you why. And finally, will the current global warming cycle continue beyond 2030? False. It will not. Well, we'll start right off here. Here is the global warming. Here's 1850. And warmest year on record, right up here, 2024. We really see a big rise here. And some people say we've never had global warming prior to 1850. This all occurred because of the increase in carbon dioxide. Well, is that true? Or do we have recurring natural cycles? Well, first of all, way back in year 990 to 1100 AD, we had a global warming cycle. They labeled that number 1. Then we had big cooling. There's global warming cycle number 2, 990 to 1110. Then a cool down, and we had global warming cycle number 3, global warming cycle number 4, big cool down, global warming cycle number 5, 1700s to early 1800s, and then our current global warming cycle. So yeah, global warming cycles have occurred prior to this one. We've had 6 in the past 1,100 years. And we'll be showing you at the end, warming cycles occur about every 200 years. And the last one ended 1830, add 200 years to it, and we come up with the year 2030. Okay, to part 1. What caused the Arctic ice to melt from the period 1990 to 2025? Well, what happens is we have a plunge of warm water about every 9 years up through the Ural Straits, plunges into the Arctic Ocean, takes it about 5 years, 5 to 7 years to go around the Arctic. And this is under the ice caps. So the ice caps actually melt from the bottom up, not from the top down. So how or what causes the North Atlantic warm water pulse in the Arctic? It's really a plunging effect due to gravitational cycles. On the bottom graphic, you can see the yellow dots and white dots, black dots. This is the strong gravitational cycles each year. This starts in 1969, and this is in the southern hemisphere. In 4 years, it comes up to northern hemisphere. 4 years later, southern hemisphere, northern and southern. And so what happened in 1988, we had a very warm pulse of water that was plunged up into the Arctic through the Ural Straits. And that occurred, just watch right here where we are on the cycle, just approaching the peak of the cycle in the northern hemisphere. And that was right at the ending of a El Nino. The next one occurred in 1998. This was 10 years later. Again, same spot on the gravitational cycle and just after the ending of an El Nino. Then we had another one in 2007. That was a very warm pulse. That was at the ending of a weak El Nino. Same spot of the gravitational cycle, exact same spot. And then the last one there was in 2016. Same spot on the gravitational cycle, and again, at the ending of a El Nino. So they all tie in together. The combination of the El Nino and the gravitational cycle cause a plunge of the North Atlantic ocean water into the Arctic up through the Ural Straits. Now, and this is available, a lot of the data is available, Bulletin of the American Meteorological Society. You can stop the video and find the link to it. Now, the next plunge, it's not in the science papers yet, but I'm saying 2025, 2024, 2025 was the same spot in the gravitational cycle. Same spot. So we have a big meltdown of the ice in late 2025, this winter, and a warm north high Arctic. So we likely had a very warm plunge at that time during late 24 into early 25. Again, that was at the end of an El Nino. So that is what has caused the ice melt. It is not carbon dioxide. The next plunge will be over here on the right. That will be in the year 2034. And I'm labeling it as a cool ocean pulse, because what's going to happen is the North Atlantic has been running very warm, above normal temperatures. In 2034, the ocean water temperatures will be running below normal. So it'll be much cooler water plunged into the Arctic. And at that time, during the 2030s, we're going to have a great increase in the Arctic ice. Part 2, how global temperatures are calculated by NOAA. and the Climate Prediction Center. Well, what they do is they take the global temperatures, ocean, land, and this was back in 2023, I think it was. And the red is very warm. The blue is cooler than normal. At that time, the Antarctic was having record cold. And Antarctic has been very cold during the past several years. And actually, right now, they have the most ice extent in 40 years in the Antarctic. So anyway, they take all the temperatures, land and ocean. And the thing is, land is 29% of the Earth's surface, oceans 71% of the Earth's surface. And look at the ocean. This is the ocean water temperatures as of March 2025. The yellow, orange, and red is well above normal water temperature. So you can see all the oceans are running very warm right now. That's a cyclical event. So they're going to take 71% of the surface of the Earth, which is running very warm, and add it into the land areas. So they come up with the warmest year on record. This is what the graphic looks like afterwards. It actually warms up the land areas, according to them. So it's a little bit skewed, is what it is. Part 3, climate change cycles. Warmest year on record, as recorded by modern instruments, and this is since 1978. Not going back very far. Well, these cycles are actually caused by, yes, the climate pulse, the electromagnetic gravitational cycles. And it's proven science, interactions between the Earth, Moon, Sun. And a typical cycle, this is the Earth over on the left. And as the Earth takes its track around the Sun, it's an elliptical path. The closest approach is in January, and its furthest away is in July. Right now, this is where we are on it. And what happens over a course of 120,000 years, or even 40,000 years, the elliptical path becomes even greater. So when it comes down around the bottom part of it, we are really a lot further away from the sun than we are right now. And this in conjunction with the tilt of the Earth on a 41,000-year cycle, where the Earth tilt changes from 22 degrees up to 24.5 degrees. So when you get the change in the tilt, where the tilt is such a way that the Arctic and Antarctic actually receives much less solar radiation. And this occurs in conjunction with the increase in the elliptical path, and you're in an ice age, is what happens. And then when it changes back, we're in the warm interglacial period like now. So humans and animals require sleep or we do not function well. And the Earth also requires rest or it does not do well. And that is why we have glacial and interglacial periods. Back 450,000 years ago, very warm interglacial period. Then it really cools down for about 80,000 years or so. And during the cooling process, the oceans extract the carbon dioxide out of the air and store it. And then when you warm up again, the carbon dioxide is released back into the air. This is cyclical. So you can see the warm cycles come about every 120,000 years to 140,000 years. And here we are today, right here. We are supposed to be warm. This is a natural cycle. And as we came out of the glacial period back 8 to 10,000 years ago, you can see it really warmed up. 5 to 7,000 years ago, it was very warm. And then we have these cycles that come every 1,500 years or so, where we cool down, warm up, cool down, warm up. but you can see they're decreasing in time. Here we are over on the right. Not as warm as 4,000 years ago or 7,000 years ago, but warm. So we are supposed to be warm. That is another cycle. That's two reasons we're supposed to be warm now. Then, sometimes we require a little nap to refresh ourselves during the day. Well, the Earth needs it also. So we have shorter cycles. And this involves the moon. The moon has an elliptical path around the Earth, just like the Earth around the sun. When it's furthest away from the Earth, this is called the apogee and the least amount of gravitational pull. And as it revolves around or tracks around the Earth, elliptical path, then when it comes into a close approach, this is called a perigee. And we have a big increase in gravitational tug, 30 to 40%. When the sun is also involved and we have direct alignment of the Earth, Moon, Sun, gravitational increase is actually all the way up to 44 to 47%. That's a lot. That causes a lot of tug on our oceans and everything else. And this is what it looks like. Strong gravitational cycles come down to the southern hemisphere. 4 years later, up to the northern hemisphere, then back down to the southern hemisphere. This causes a great tug on, well, the oceans. It's like a plunger. And on the crust of the Earth, it causes earthquakes and also changes in weather systems. And it can even increase volcanic activity. And we have many cycles involved in this, anywhere from 4-year cycles out to 72-year cycles, 1,200-year cycles, and some other cycles. So this is what a typical cycle looks like over the course of 1,200 years. Remember, I showed you the global warming cycles past 1,200 years. It looks pretty similar. This is the gravitational cycles. And let's overlay it onto the global warming cycles that we've had during the past 1,200 years. And look at that. Matches up. That's what causes our global warming cycles, the gravitational cycles, electromagnetic. Everything in the atmosphere, even our bodies in the universe, is electromagnetic. Part 4, atmospheric concentrations of carbon dioxide. Is the rise in atmospheric carbon dioxide since 1850 caused by human activity, such as burning of fossil fuel? And we've been told if we don't stop it, the Earth will die in 12 years. Well, we only have 6 years to go now, 2031. So getting pretty close. Better get ready. But we're going to investigate this. This is the carbon dioxide cycles during the past 800,000 years. This is way back in time, and you can see very cyclical carbon dioxide cycles, very cyclical, very, very cyclical. This is 100,000 years ago. These all occur on the interglacial warm period when the oceans warm up and release the carbon dioxide back into the atmosphere. And here we are today. This was 1956, right where the arrow is. That is when they started instrument readings. And look what happened. It went straight up. Well, that's a red flag. That is a real red flag, because the rest of this was not taken from instruments. So let's take a look at that. Here are the glacial and interglacial periods during the past 450,000 years. The red is temperature. 450,000 years ago, we warmed up greatly. The blue line is carbon dioxide. Carbon dioxide follows the increase in temperatures. Temperatures go up first, followed by carbon dioxide. And we peaked out, according to ice cores, 280 parts per million. We're going to be taking a look at that in this presentation because these are estimates taken from ice core samples, just estimates. And the calculations need correcting, and I'm going to do a correction for it. Then when you go into glacial period, you can see temperatures fall off rapidly. But look at the carbon dioxide, lags way behind. It takes time for the oceans to absorb the carbon dioxide. Then the next global warming cycle, same thing. And we come way over on the right. And this is our current one. Temperatures up. Carbon dioxide is actually up at 425 right now. And everyone is saying, wait a minute, it's up to 425 parts per million. We've never been above 300 parts per million because there's 287, 278, 298, 280. We are going to investigate this. Historical concentration of carbon dioxide. Well, I'm going to show you that it's much higher than reported by the political science. One study, they take stomata cells. This is in a leaflet. They take fossilized stomata cells, and they do not change over time because what they're looking at is the stomata cells inside. And being fossilized, they stay at the current number. So what they look at is how many stomata cells are in the leaflet. If you have a lot of stomata cells, that means you had low carbon dioxide in the atmosphere. You needed more cells to take in the carbon dioxide. If you have very few stomata cells, that means you had so much carbon dioxide in the air, you didn't need very many cells to bring it in. And the good thing about the leaflets and carbon dioxide is, I guess I didn't have it on there, but the leaflet takes in carbon dioxide, and what is the byproduct? Gives off oxygen, and we need oxygen. And this is what the study came up with. This is back in 800 AD, 1200 years ago. That shows that the carbon dioxide was up to 375 parts per million in the atmosphere. Ice cores say it was only about 290. So you've got about a 90 parts per million difference in the two studies here. Then you can see on the global warming, global cooling cycles, how it peaks, cools off during global cooling cycle, peaks, cools off. Here we are on the right. This is in 2010 when this study concluded. The parts per million in the leaflets was 375. It's probably up to 387 right now. But everyone says we've never been above 300 parts per million. Well, let's take a look at that. Ice core samples. This is what everyone uses. Ice core samples. Are they accurate or are they not? Down in the Antarctic, they drill down as much as 15,588 feet. Ice down there is almost around 500,000 years old. And trapped in the ice is ice bubbles. Not ice bubbles, air bubbles trapped in the ice. And the air bubbles hold or have within it the atmospheric gases, carbon dioxide, for instance, oxygen. So we can measure to some degree what we had at a particular time. Now, there's a couple problems on it, though. New ice, which is the first 5,000 years of formation, that covers about 688 feet of the ice. That's a lot. That's the first 5,000 years. But air bubbles are not locked in place, which means the air bubbles leak carbon dioxide back into the atmosphere. And a study said it was about 2.5 parts per million every 44 feet. That means you've lost at least 30 parts per million in the ice core readings. So you need to add 30 parts per million back into the reading, such as we had one interglacial period that was said it peaked at 297. Well, you got to add 30 back into it. And then you have to add another 60 if it's going to be sort of like the leaflets, the stomata cells that I showed you, and the correction of taking a mean. The problem is they take a mean of this over a 2,000-year period. So they'll take an ice core, look at the air bubbles and sample it, but they'll take a mean value over a 2,000-year period. Well, during a 2,000-year period, you have about 12 global warming, global cooling cycles. So it's going to be up and down, up and down. So you're just leveling it off and you're not getting the true reading. So what we have to do is add another 60 parts per million. And that takes us up to 387. That is my corrections. So what we have, bottom line is, rise in atmospheric carbon dioxide since 1850. NOAA says it is 100% due to fossil fuel. 100%. 150 parts per million increase. Well, my study shows that it's 80% natural. Only 38 parts per million due to the industrial. Another study done by Scrabble et al., and I'll show you how to find that one. They agree, 80% natural. And the plant stomata, 80% natural. So when we look at it, this is the increase since 1750. The red is what NOAA says is, NOAA and climate prediction, is the increase in carbon dioxide due to burning the fossil fuel. The green is natural. So they're saying we're up to 425 parts per million. The increase of 150 parts per million since 1750, they say is 100% due to the burning of fossil fuel. Well, that's incorrect. It's 80% natural, and that's the only increase. That is far too little fossil fuel from burning fossil fuel, far too little to cause climate change. So here's the readings from the ice core samples. As we said, it's never been above 300 parts per million. This is back 425,000 years ago, was 280 parts per million. Then 325,000 years ago, 297. And you can see we've never been above 300 parts per million. Right now, we're 425. That is what had everyone scared. But now let's put in our corrections. Here's our corrections. This is what it should be. 378, 355, 376, 390, natural, and we're at 425. That is far too little of a rise due to fossil fuel to cause any change in the climate. And this is the sources. You can stop the video. Plant stomata cells, Scrabble et al. In the on the carbon dioxide, and mine on podcast number 64. Tom Nelson brought podcast 64. I went over that pretty good. And this again is the Health Physics Journal. And a lot of people like the graphic I show here is the gases in the atmosphere. How much is what? For instance, 78%, which is 780 parts per million, 78% of the atmosphere is nitrogen. People don't know that. 21% is oxygen. Used to be 34% when the back when the dinosaurs roamed. We're getting oxygen starved because we don't have as much carbon dioxide in the atmosphere. And then where is carbon dioxide? Could it be this one, this little spot here? No, that's 0.9%. That's argon. Okay. So this next one here, that has to be carbon dioxide. Well, it is water vapor. So where's carbon dioxide? Water vapor is 1 to 4% of the atmospheric gases, it's variable. Well, carbon dioxide is variable also. So we must have a big line here for carbon dioxide. No, it doesn't even show up because it varies only between 0.025 to 0.04%. That's 4/1,000ths of 1%. That's not enough to cause problems. That's detailed in Tom Nelson podcast number 67. Part 5, solar cycles and climate change. Solar cycles, this is back 1880. The red line is the world temperatures. Yellow line is solar cycles. That's the amount of solar radiation coming in, which varies. And you can see that they line up pretty good. This is up through 1940. World temperatures bounced up a little bit in 1940. That's because the Pacific Ocean and Atlantic Ocean was in a warm water phase at that time, came into a warm water phase. So that's the reason the temperatures bumped up there. So then it was in alignment pretty good. And then now it's big separation, and that's because both the Pacific and Atlantic are in a warm water phase, plus we're using instruments to record the temperatures. So that's a big difference. All in all, the solar cycles, this is back in 1725 to 1790. This was a global warming cycle, or this is the insolation, I should say, the solar cycle, and it lines up with the global warming cycle. Then a cool down, and then we came into a big solar cycle again in 1960, right up until now, and that's our global warming cycle. So they line up with our global warming cycles, and what's happening now is we had all the solar flares back latter part of last year into early 2025, into January, all kinds of solar flares. You'd say, northern lights, northern lights. That's due to we had a kind of a peak in the solar cycle, just like fireworks. You go out and see a fireworks display and they have a grand finale. This is, or was, the grand finale on the latest solar cycle. And that solar cycle is now ending, and it's going to go into what they call a Maunder minimum in the 2030s. That means less solar insolation irradiance for the high Arctic. That means the high Arctic will cool down rapidly. These cycles warm up. So this is another cycle that is going to be changing. And then the next global warming cycle won't be until about 2120, quite a ways away. And I should show you the red dots here. That's the global warming cycle. Lines right up with the solar cycle. Part 6, ocean temperatures. And this is really important. This is January 2025. Again, the yellow, orange, and red is warmer than normal water temperatures. We only see a little bit of blue mixed in there. In the central Pacific, we have a little bit blue because we had a very weak La Nina out there. And the Atlantic Ocean is all pretty much warm. So what we see is 71% of the Earth is really running about above normal water temperatures. And remember, this is how they figure out the global temperatures. Now, the Pacific Ocean, since 1500 AD, has cycles. There's a warm, cool, warm cycle in 1630, warm cycle in 1720. So you can see the cycles. And we're currently in a warm Pacific Ocean water cycle, which is going to end by 2030. It'll be cooling down. So you will not be able to add that into global warming. Well, I'd have it ending 2024. Actually, as my update, we're going to have a strong La Nina in 2029. That's when it'll be ending. The Atlantic Ocean also had cycles back in the late 1800s to 1900. very warm ocean cycle. Then it cooled down for about 30 years, warmed up, cooled down, and we're currently in a cyclical warm period that'll be ending in 2030. It'll be starting to cool down in the next year or two, and it'll be down to about normal right around 2030. So the oceans are all going to be cooling down. And as I was indicating, we're going to have a big El Nino probably in 2027, 2028 that will warm up part of the Pacific Ocean. That's the ocean water temperatures. But then a strong La Nina in 2029, 2030, and that will really cool down the Pacific Ocean. So what's going to happen? This is March of 2025. The ocean's all warm. It's going to warm up again a little bit in 2028 with the El Nino. Then it's going to, let's see, strong La Nina coming in 2029, 2030 and beyond. That area is going to be cooler than normal. Then the northern area up towards Alaska will also be cooling down, and they'll be running normal to below normal after 2027 to, about 2029, I should say, up through 2055. And the other parts of the ocean will also be cooling down. Atlantic Ocean will be going into its cool phase by 2030. So that's going to be cool water also. So you've got all this area that's going to be normal to cooler than normal by 2030. And remember, I said that NOAA and Climate Prediction Center, they add up the whole Earth's surface. 71% of it is ocean, 29% land. Then they average it out. And that's why we've been so warm. Well, by 2030, 31, somewhere in there, if it's like this, global warming is dead. You can't have it. We'll have colder than normal winters as you take the average, or years, I should say. Part 7, we're getting towards the end. Climate Outlook, 2030 into 2021. Real science is what I've been showing you versus political science. The current global warming cycle was caused by 5 natural cycles. As I noted at the beginning, the 120,000 year interglacial cycle, we're at the peak of it now, coming off the peak, right at the peak. So we're supposed to be warm right now. 1,200 year ClimatePulse warm cycle, that's the global warming cycle that comes every 200 years. We're at the peak of that, coming off it. We're supposed to be warm now. That's the 200-year cycle. Pacific and Atlantic ocean cycles, they're going to be going away. And the solar monitor is also going to be decreasing, coming into the solar monitor in the 2030s, and that's going to end the warm cycle. But all these cycles peaked altogether, the 5 cycles during 2025. And 2024, I should say. 2024, they all peaked, and that's why we're so warm. 2030, they're all going to be well out of their peak, and global warming will be dead. And what will happen is, when we go into global warming cycle, the Arctic warms up. And because of that, you have less cold air to come down to mid-latitudes, and you have global warming. And then when global cooling begins, and in high Arctic, they did have their coldest spring and summers in 2022 and 23, but it warmed up this winter, because of the ending of the El Nino, and also that one spurt in the solar cycle. But that's going to be ending, and in just a couple of years, it'll become much colder up in the Arctic, and this will spread down into the mid-latitudes and will be entrenched in global cooling by 2030. And this is our 6 global warming cycles. The global warming cycles end. This one ended 200 years after that cycle. This one ended 240. This one ended 200 years after. That was 230 after, and this one will end 200 years after. And that means 1830 plus 200 equals the year 2030. So gathering our thoughts here at the very end, understanding global warming. Yes, use common sense. And thank you very much for having me on, Tom. And this is my contact information. Either here or Dilley at globalweatheroscillations.com. And this is the website.
Yeah, maybe I missed it, but what do you think that the UAH satellite data will show in the next, let's say, 10 to 15 years relative to the temperatures in 1979, let's say?
Relative to this, okay, well, by 2035, we're going to have temperatures much like the 1970s. And by 2040 to 2045, we're going to have temperatures like the 1940s, 50s, and 60s. And that's what they'll be showing on the data. One thing to remember is it took us 20 years to build up on global warming since about 1994. And it's going to take us about 10 years to get into the real heart of the global cooling cycle, which will be right around 2035. We'll really be in it pretty good, very cold.
All right. And there was this 1976 Pacific climate shift where temperatures around Alaska, I think, changed dramatically in a year or two. Do you see anything happening that dramatically going the other way? Or again, it's going to take time, like you just said.
That was what year was the change?
1976.
That's they had a big climate change in 76.
They did.
That was probably the solar cycle that was starting to warm up the Arctic area. That helped to warm that up. And the Pacific Ocean came into a warm cycle right around 1997. The Pacific Ocean warmed up. They've been in the cycle for about 42 years. And that's the pretty much the longest period that the cycles go. So yes, I would see a major shift again in Alaska coming up in the next couple of years.
All right. Valentina Zarkova has said that she thinks maybe the Thames might freeze over in upcoming decades. Are you predicting anything that dramatic?
Oh, yes. I've been tracking the cycles on there, and I'll look at it on my next winter forecast, but they will, once we get into the 2030s, yes, it's going to be cold enough, the Thames will freeze over.
All right. And it sounds like you are kind of on the same page with Zarkova then on a lot of this stuff?
Oh, yes. Oh, yes. Everyone using the natural science is pretty much on the same page. You have to look at all the cycles, the ocean, especially the ocean, the gravitational cycles. You definitely have to look at those. They tie in 100%. And it's all natural, and hopefully we're going to get a change in the grant system to universities. I'd like to see the grant cut for tying in fossil fuel to climate change. I'd like them to put out more grants, issue more grants for natural cycles.
Do you see any trends coming up in bad weather in general, in terms of droughts, floods, et cetera, as the global cooling sets in?
Well, places like California have natural cycles even during global cooling, natural cycles of droughts. They often go into periods of 3 to 7 years of droughts, and then very rainy periods. And that's all cyclical. It's nothing to do with human-induced climate change. Everything is cyclical. So, yes, but it's always going to be someone will always be getting a drought. Someone always be getting floods. And we've had a lot of floods lately, and that's because of a fight between global warming and global cooling. It's part of that. The cool air fighting with the warmer air. And we've had a pretty cool winter over much of the United States. And however, the Arctic is still running above normal temperatures. And that's due to the ending of the El Nino that we had in 2024 and the gravitational cycle that plunged the warm water up in there. But everything will be changing. We're going to be seeing huge changes. Mainly, the biggest changes will be coming in 2029 and 2030.
All right. And it is going to get much more difficult to grow grain further from the equator.
Well, that's for sure. They're trying to grow more produce in the northern latitudes up north, and they need to be prepared for colder weather instead of saying, oh, yeah, it's going to continue getting warmer. They're going to put a lot of people into bankruptcy. As we cool down, you're going to have shorter growing seasons again, and everything's going to change. And we really have to prepare for it. It's, we've been so warm the past 10, 15 years. Everyone has a mindset now that, oh, it's going to be like this from now on. No, it isn't. We can, if you're old enough, you can remember what it was like in the 2050s and 60s. It was really nasty cold.
How do you think the mainstream media is going to handle this? Are they going to continue to say that the current year, well, it wasn't the warmest year ever, but it's a top 5 or top 10 warmest year? Are they going to just cling to this warming narrative to the bitter end?
Well, I'm sure they will to the bitter end. And the big change will come when the Pacific Ocean and Atlantic Ocean go into their cool phase. They're going to gradually be cooling. And then the big cooling will be in 2029 with the strong La Nina. But they'll hang on until 2029. And then NOAA and the Climate Prediction Center will not be able to put out a narrative that, fifth warmest year on record or second warmest year. No, it's going to be more like the 30th coolest one or something like that. They're going to have to change their whole narrative at that time. Well, the big thing is you're talking about the media, and media has to change. And one thing I'm hoping is with our new administration, we'll start getting a narrative out on the climate change and get some changes in the grant system. And even Europe is starting to think a little differently on the climate change issue. So we really need, first of all, the grant system. Number one, I feel needs to be changed to where we get more research papers out on natural cycles, and that will get into the media. And right now we don't have that. And that's where we're losing. But if we can get more research out of the natural cycles, then the media will have to start waking up a little bit. But like you said, they're going to hold on to this, especially with Donald Trump in office. They will hold on to this to the dire end. And even when we get some very cold winters, first couple winters, we'll hold on probably for a couple more years even. And then they'll start saying, oh, carbon dioxide caused global cooling, is what they're going to say.
Are you seeing any movement at all right now towards sanity, towards real climate scientists getting some funding, or not happening yet, even under Trump?
Not yet, I haven't. But I think with the funding that the Trump administration is doing on cutbacks, they'll probably, hopefully, make a change on the grant system to do with this also. Hopefully, we'll see a change there. But they've only been in there 30 days or so. Right now, we're March of 2025, so we'll probably won't see a change until maybe during the summer or so.
All right. Anything else?
I think that's about it. We just need to tie in all the cycles, and the big thing is we need people to learn the natural science. And this is a problem in our education system right now, where they are not being taught the real science. And as you said, in the media is putting out the wrong information, skewed information. And you have to see the whole picture to understand what's going on.
Are you having any luck at all in attracting younger folks into so you can pass your knowledge on to them, people in their 20s and 30s?
I have a young man that really wants to come in and take over eventually. He has another year of schooling, but he's studying geology, but he's going to take some meteorology this coming year, and then he'll get a better background. And he's a very knowledgeable, bright man, and he'd love to take it over. And this is what I'm trying to do is find some contacts. I'm getting up in age and slowing down. I need to find meteorologists, climatologists that would like to come in and help out in global weather oscillations. I can mentor them in on what I'm doing and eventually have them be the principal player and take over.
Yeah, I hope that happens. That sounds fantastic.
I hope so. I'm trying to find a way to make some contacts to have this happen. Because I want what I have to continue, especially on the ClimatePulse technology that I have developed.
All right. So your email address is on the screen here now. So I guess if people are watching this, younger folks that are interested in working with you, they could contact you and see what happens.
Yes. And actually, I should have it on here too. My email address at the company is Dilley, Dilley, at globalweatheroscillations.com. But you can just email me at my just little private account that I have on there. That's fine also. Or they can go through the website and just click on contact.
Perfect. All right. Thank you very much. Super interesting stuff. Thanks for being on the podcast again, David Dilley. We'll talk to you next time.
Thank you very much.
Goodbye.